Obviously, firstly, thank you very much for the awards team, Jose, Sarah, especially for inviting me here today. After following Greg Bath, I'm astonished that I'm here. That was truly amazing to see. So apologies for following that. This is the first time I've been in Amsterdam for about 10 years. The last time I was here, I was an innocent, youthful 20-year-old, and I don't think I remember that trip. So I'm very fortunate to be able to remember this, having in a working environment, which is great. Everyone guessed already, my name is Patrick Hamman. You can catch me on Twitter at Patrick Hamman, and most of the other social media haunts along that title as well. If you haven't guessed already, I live in London for the Financial Times. We are the world's leading news organization on business and economic affairs, if you don't know them, where amongst other things, I'm helping to build the next generation of ft.com. It's a completely responsive rebuild. We're not touching a single line of code from the old code base. It's all the buzzwords, microservices, Node.js, whatever. It's a very fun project to work on. But I'm not actually here to talk to you about that today. Why am I here? It's a very good question. Hopefully, all will be revealed. But to start that, I want to ask who in the room is a designer? Quite a lot of you. Who's a developer? Or who associates yourself with being both of those things? Yes. Who doesn't even know why they're here? Right, we need to talk. So the reason why I ask this is one of the main things that we all have in common as designers and developers, and everyone here in this room, is that we probably all build products on a daily basis. And at some point in their life cycle, those products are going to be delivered over a network connection. And more so, we tend to rely on this network for our users to perform tasks and interact with the products that we build. It's innate within the products. The web is the largest distributed network in the world. And this is an amazing thing. The A and the link element are the world leaders of distribution, all the way from their inception at CERN by Tim Berners-Lee years and years ago. This has been innate within the technologies that we use. And because of this, we can reach and connect more people than any other technology can even dream of. And we're about to get even further, as Dave was talking about with the Internet of Things. This surpassing, we just don't know what to do with these networks. But sadly, even the greatest things in the world have a tendency to fail. And we, as application designers and developers building products, have been trying to shoehorn these old desktop experiences into mobile devices, into mobile experiences. And this is beginning to hurt. But most importantly, for our users, this really, really hurts. Due to the varying conditions in networks that we see across the world and the incredible diversity at which people are accessing our products now, the plethora of devices, the different networks in every single country, our applications are not living up to the contracts that we are making and we are building with the products that we build and our users. These contracts are failing. They aren't dependable. And this is, to be fair, this is not the fault of Medium.com. It just so happened that I had a flaky connection when I was researching this product. The FT has got exactly the same problems, and probably most of the products that you build do too. We no longer have control over the distribution of the network. Networks can and will fail. HTTP requests will drop, they will hang, they will time out. And so we need to know, as designers and developers, what we can do to solve this, or the impact that it has on the end users of our software. In 1994, Peter Dusk of Sun Microsystems at the time, he coined the 8 fallacies of distributed computing. Now, the ironic thing here, this is over 20 years ago, but every single one of these points is still relevant today, if not more so. Networks are definitely not reliable. Latency, especially because of mobile, has grown tenfold. There are millions of administrators. When your user requests a web page, the packets traverse across a network of servers and proxies. Every single one of them has got an administrator applying their own rules to them. This didn't used to happen. And mobile costs are extremely expensive. I don't know about you guys here in the Netherlands, but my 3G connection back in the UK cost me an arm and a leg. And the network is definitely not homogeneous at all. A user accessing ft.com in China is on a certainly different network to, say, one here in the freedom that we have in Europe. But this is quite new, in the grand scheme of things in history. And the FT has actually been delivering content for hundreds of years, 128 to be precise this year. But the difference here is that it was originally on a very different medium, a very predictable medium. Guess what? It's paper, right? We owned the distribution network when we were delivering our content on paper. Everything from the printing press to the delivery vans to the shops to the second it gets into the user's hand, publishers had control over the distribution network of their content. Yet the internet has completely changed that, and the way that the networks are formed is changing that. And unlike paper, we are starting to create dependencies of other services to deliver or even render our content. The average web page now takes up to 80 requests. On any given average, that's the median average, that's shocking. Some of which are even depending to even render our content. Your user will not see anything until a third-party request is made. A recent New York Times study showed, literally at the end of last year, that 50% of all mobile data now is advertising, third party, not the content. I don't know about you as well, I find that astonishing. This map is taken from a tool called Request Map by a friend of mine, Simon Hearn, made, that you can type in a URL and it will draw you a spidergram of all of the other requests that individual content page is doing. This is ft.com's homepage. All of the blue lines are third parties that we're depending on to deliver our content. And remember, we think back to paper, that didn't happen. Yet, unlike paper, each one of these requests has a potential to fail, especially now with the rise of, say, content blockers that are becoming on our devices. Users can explicitly block requests. Before, it might happen because the network request was flaky. Now users are choosing to block certain requests. And therefore, if you create a dependency on this, they could potentially even be blocking your own content. Now, I think that we should be spending a little less time trying to stop the inevitable from happening and a bit more time trying to deal with it gracefully. I'm truly amazed at the amount of organizations that are process and controls in place to try and stop the failure from happening, from even walking out the door, but little to no thought into actually making it easier for us to recover from failure. We need to accept that a failure can happen, just make it easier to recover from it. So if we imagine that your web page has a product has 1 million page views a day, a 3-year product lifecycle. I've just noticed a typo in that maths there. We don't have 360 days in the year. Anyway, so 1 million times 360 times 3, that's 1 billion opportunities for something to go wrong in your product. And I don't know about you, but that scares the shit out of me, thinking that my product, when it goes out the door, has that much opportunity for failure. So this can be distilled down into what is known as Murphy's Law, or anything that can go wrong will go wrong. I like it that Sam Newman last year, he's of ThoughtWorks, released a book on O'Reilly, building microservices, and he discusses how we should overcome this fear as designers and developers when we're making our products. He says, but by baking in the assumption that everything can and will fail, will lead you to think differently about how you solve your problems. And this has been really iterating back in my mind, and I've been thinking about this a lot over the past years. And this is what I want to talk to you about today, about how we can overcome this fear of failure, especially around networks when we're building our products, and we can build more resilient applications. So now that we're all in agreement that failure will happen, the rest of the talk I'm going to cover how we can be resilient against it, test, design, and build products that truly embrace the unpredictable nature of the network that we deliver our products over. So how can we test failure in our individual services and the connections that we're creating between them, and add this to our day-to-day workflow? So I mentioned earlier, we're starting to rely far too much on third parties to deliver our content, such as adverts or analytics trackings that we're adding to it. And some of these things lead to a SPOF, which is a single point of failure. So single point of failure can be described as something that a part of a system that if it fails will stop the entire system from working, and they are undesirable in any system with a goal of high availability. And I don't know about you, but I definitely want my system to have high availability. Google's DFP advertising network, which stands for double click for publishers, they, on any given second of the day, right now, serves, on average, 35 to 40% of all of the adverts on the internet across the millions of websites. And on November the 12th, 2014, DFP went down for 5 hours. This costed an estimated $1 million a minute to our industry. That shows you how much. That's 40% of all adverts on the internet at one time. And many of the websites that you visited look like this. This is taken from one of the FT's competitors, Forbes. Your users would go there on that day, and the website was just left blocking, waiting, and waiting for the adverts to load. Even though the user actually came to read the news, they were left with this. This Dynatrace graph shows the impact that that had across all US industries on that day. Your average web page normally took around 4,000 milliseconds to load. On that day, on November the 14th, actually 12th, it went up to 18 to 20 to surpassing to 70 seconds. But imagine what your users are probably doing at that time. They are leaving and going somewhere else. Now, the reason why I know and remember this day very clearly is when I was working at The Guardian at the time, and we had implemented asynchronous adverts. Therefore, we had removed the coupling between the adverts and our content. And literally, The Guardian owned the news that day. Every single one of their major competitors, be it from the BBC to the CNN to New York Times, all had blank pages. The Guardian was the only newspaper you could go to read the news. And that was a single point of failure. So how can we test against this when we're building our products? Who here has heard of web page tests at all? So not only a few of you. It's a great tool that you can use. It's open source, and anyone can use it. You can put in your URL, and it will give you synthetic testing and show you how your website is performing. Now, a little unknown feature of this is the single point of failure tab, the SPOF tab. And what this allows me to do is put in any host name that your website might depend on and test to see if that host name was down, what would your website look like? Would it still perform? And so here I'm testing the FT's current homepage, and I know that there's a JavaScript that we're loading from this host here that is blocking, and we don't actually need it to deliver the content. It's not what the user came there for. So on the left, we can see the normal website. On the right, we see it as if that host name failed. And we don't actually have that good start render at the moment. We're trying to solve that problem. But imagine what the user is doing here. They're just sitting, waiting, and waiting. They would have bounced and gone to one of our competitors now. Facebook could take this to this degree of testing even further, that they last year announced 2G Tuesdays, where on Tuesday across all of their offices, they are going to restrict the network for all of their employees down to a connection speed of 2G. I think this is amazing, and this shows that everyone in the company should be accountable for what the product feels like, and it will allow them to identify what their product really feels like for some of their users in developing countries or people just on a flaky internet connection, and holding everyone accountable for it. I think this is an amazing that I think we should all try and strive towards, to be this level of testing. And so you might have all heard famous case studies from e-commerce platforms such as the likes of Amazon have announced that for every 100 milliseconds they shave off their loading page, they increase their revenue by 1%. And I don't know about you, but I dread to think what 1% of Amazon's revenue is. The problem that we had at the FT was that it's very easy to correlate conversion in e-commerce, and it's not that easy to correlate speed and conversion in a media site, such as a newspaper. And so we had to take this into our own hands, and we decided to A/B test and try and what the impact of performance was to our own engagement and to our own KPI metrics. So we had our new website, which was the control group, and we slowed that down purposefully for 4 other groups, so 1 second, 2 seconds, 3 seconds, and 5 seconds, and measured our core level, top-level KPIs against this. And it was very unsurprising to me, but surprising to a few of you, it had a dramatic effect. So here, the outlier here is the 5-second one, and it's measured against the depth of the amount of pages or articles that user read in that session. And we can see that around 4 or 5, it has a dramatic effect on slowing down your website. Therefore, if you had failure or a flaky connection, it's actually going to be damaging to your top-line metrics and your revenue. So to summarize with that, we found that 12% was the golden number, that users on the slow site consumed 12% less content. And if you relate this maybe to our advertising, you'll see the impact that that has on our business. 12% less advertising revenue in a year if we had a website that was rendering between 3 and 5 seconds. So these are all still controlled environments. What are our users actually experiencing in production? And so the first thing we can do with this is we now have the user timing API in JavaScript against the window.performance object. And we're seeing a tectonic shift in the performance industry at the moment where the golden metric of your window on unload is no longer truth. It's a fallacy that every different web page is different. The rise of single-page web applications now and lots of JavaScript means that just when the page loads does not necessarily mean when your application is actually actionable by the user. Can they actually interact with it? And only you as designers and developers know what these points in the application's lifecycle are. So now we can actually set a mark of saying this was an important time, and maybe another one, and measure these. And the great thing about this is because it's on the user's client, we can then beacon this information back as analytics and track this in real time. So Chrome Canary now visualizes these metrics in the developer tools, which is amazing. This just landed 2 weeks ago. And so I've made 2 custom measurements here, and I can see, as I'm developing, constantly reloading my features to see what this is like. We can then beacon it back. So we set a performance mark when our fonts is loaded, because that is something relevant to us. We know that the second that the fonts are loaded, therefore the text can be rendered, therefore the user can read the content they came for in the article. But this will vary depending on the user's network condition or their device characteristics, and then we can track this in real time and see. So we've actually got a font loading problem, which I'll talk about later. User timing allows us to change and track our custom measurements in real time. So in this section, we've learned that we need to test first and third-party dependencies or single points of failures. Whenever you're adding something new or a new third party to your website, please do this. Try and simulate network conditions using dev tools or web page test. Mark and measure your custom events. And always monitor those custom events and alert if they pass their thresholds in real time. So it's quite a common practice these days to test and monitor failure. But something that I think is often forgotten when we think about resilience is how we communicate failure to our end users through good design and UX. At the end of the day, performance is UX. Fast-loading websites mean your customers get exactly what they came for as fast as possible and will not go to one of your competitors. So rather than designing for the best-case scenario on our shiny MacBook Pros in our office with our T1 connection, we need to be designing for reality, because obviously our users live in the real world and are experiencing your product they might be on a bus, they might be on a train, they might even be on their bike. So at an event apart in Seattle in 2013, Luke Robolski explained that his team had worked hard to develop their new voting app, Polar. It's since been acquired by Google towards the beginning of last year. And one of the things they focused on was the performance and the loading of their polls, because that was their core product. And they were so happy that they'd managed to shave 200 milliseconds off their load time of the polls. And they did this by asynchronously loading in the data. And so whilst the data was loading in, they displayed a spinner. But as soon as they shipped this feature, feedback started piling in of like, but it seems really much slower. What have you done? And actually, in reality, they'd made the app faster, but to the perception to the user, it felt much slower. And why was this? So they took this back to the drawing board, and they tried out and A/B tested a lot of features. And what they landed on was that they replaced the spinners with what they've now coined as the phrase of skeleton screens. Maybe some of you have heard this technique before. A skeleton screen is essentially a blank version of the page, but with placeholders of where, if you know you're always going to have that data, why not instantly render that as part of the loading, and then as the data flows in, then show it. Now, this gives a sleight of hand, the magician's touch, to the user, that to their eye, it perceives that the web page has loaded, even though the data is coming in slowly. And so once they shipped this, people were instantly impressed by how much fast their polls loaded. This technique's become so popular now that even you might have noticed it on Facebook's newsfeed does it. When I was researching a recent trip to Sydney, I noticed that Booking.com, based here in Amsterdam, did this. Why load in all the data for those points? Whereas at least give the user some feedback. As they hover over a point, show a skeleton screen, and then in the background you can go and load that data, because they might not even choose to do that. And eventually display the data on top, replacing the skeleton. Now, there's genuine scientific theory behind this technique. HCI research has proven that for a user to perceive that a machine is working, we must respond to their interactions within 1,000 milliseconds. Anything after that, you are likely to have a mental context switch. And this doesn't just need to be related to websites. This could be any system you're working with. I could be sitting at home on the sofa. I change the channel with my remote. I want some feedback from that interface within 1,000 milliseconds. If it took too long, I probably thought that the batteries would die in my remote. But as we mentioned earlier, all failure is inevitable. And you get put up, why is it that we constantly think that, oh, we don't have to design the error state for our users, and we have this error code 5296, and what the hell does that mean to your user? My banking website is very bad at this. I make a payment to a friend, and I click the pay button. It gives me no feedback that they actually didn't send. There was no error. Did the money go through or not? It's extremely frustrating. So we need to be echoing familiar patterns that we have within our applications, even within our error state. So here's a great example again from Polar, that it was a voting app. I'm very used to saying yes or no to something. So even when something went wrong, they've given me the familiar UI of, do you want to try loading that photo again? Give up or try again. That's a pattern that as a user I know very well. And the great thing here is they've also used very human-friendly copy messaging. Oh no's, not error 2659, please send this to our developers. And as our applications are becoming more and more long-lived sessions, especially with the rise of JavaScript, these sessions could span hours, if not days. And if I have Gmail open for a very long time, I'm going to go in and out of a network connection. And so why not convey the state of the network to the user? Be honest to them that actually you're offline now, you might not be able to perform all of your interactions, but you could probably still perform some. So here is a great example from Google Inbox there. They're telling me that I'm offline, but I still know I can safely perform other interactions. We need to be conveying this state of the network to our users. So we've learned that we need to respond to any user interactions within 1,000 milliseconds. Where possible, avoid loading spinners. But if you do have to use them in context, so only within the button, not a big global one. Consider using skeleton screens for your loading instead. Try and reuse familiar UI patterns, even in the states of failure. And try and visualize the state of the network. And always be friendly. So we've discussed how failure can happen, how you can synthesize and test that failure in controlled environments, and how our interfaces can actually respond and create pleasant user experiences, even in the state of error. But how can we truly embrace failure within our code? The following collection is a collection of patterns that we've been beginning to use at the FT to how we can defend against the network failing as we're building applications and ensure that we're building resilience. So the easiest way to avoid a network failure from actually happening is to create and preempt these connections even before a user or even the browser does this. And so we now have the ability to do this with the resource hints API. So the above is taken, it's a waterfall segment taken from web page tests. So every request that we made is made up of this dynamics. It's a DNS lookup, so it's converting that human-friendly ft.com string into an IP address that we can then start a TCP connection with. So we then have the initial connection. That's a three-way trip. If you're on HTTP, if you're on HTTPS, I hope you are, you then also have to do an SSL negotiation to ascertain that you actually are the person that you say you are. And eventually, at that point, we then have a connection open that we can perform the HTTP request of get me that index file. And on a good 3G connection here in Europe, that trip will take between 600 to 1,000 milliseconds. And that's on mobile. So if you can imagine your average web page here, I have to go and get the HTML. I then get some CSS because we can't render the blank page without any CSS because it will look unstyled and we'll have to repaint again. So then we have to wait for that to download. But then the CSS references some nice shiny fonts because we all love shiny fonts. But again, the browser can't do anything until it gets that. So we've incurred 3 round trips here, each incurring 600 to 1,000 milliseconds before we can even render anything to the screen. But as designers and developers are building this product, we know that the shiny custom font is there. So why couldn't we give a hint back to the browser of actually this resource you will need? Go and pre-connect to that hostname first. And that's what the resource hints enables us to do. So here I've told it in the bottom one to pre-connect to this WAF2 file, this font file. And you can see the dramatic impact and the reduction of time it takes to render to the screen. And so how you can do that today is just using a link element, just as you would link to a style sheet or a font using the pre-connect. If it's cross-origin, you have to declare that. Or I think it's extremely powerful. You can even do it dynamically with JavaScript. Imagine you have a button. When you click on the button, it opens up a carousel of images that your user is going to go through. Those images are going to be hosted off a different hostname. Why not, as the user is hovering over that button, drop a pre-connect link, and the browser in the background will go and create that connection and start to fetch those resources. So resource hints isn't just limited to pre-connect. We also have pre-fetching, so actually fetching whole resources for the next page request. This is great for checkout flows if you know that another bit of your JavaScript application is going to be loaded on the second page. And extremely powerful, but only use with caution, pre-render. So what will actually happen is you can tell the browser to pre-render a whole nother page in the background, in a background tab. Yeah, again, this is probably very useful for checkout flows or something that you know that the user is going to be going on to that next page. And therefore, when they do click to navigate to the next page, it will be instant. But the reason why I say use this with caution is that we don't want to go and load loads of resources that your user potentially might not even go to. And only landed literally last week in Blink by my dear friend Awwwards, we now have preload. So on the same on that same navigation, we can then tell the browser that I know I'm going to use these 3 resources in this page session, but I don't need them now, but I want you to go and download all of it first. And we can now have the ability to do that with preload. And the preload, again, just looks like this. It's another link element. So I'm telling it to go and preload this other CSS file. And then once you've loaded it, then perform this function, which is actually going to inject it. And the great way of this is if I have non-critical CSS resources, for instance, that I don't actually want them to block the rendering of the page, so I can make my page render faster, but I will need them later, I can get the browser to preload them with resource hints. I can't not talk about network and not talk about HTTP2. HTTP 1.1 was finalized in 1997. It's the underlying transfer protocol of the internet that we all use. We now have a second version. And it was designed with performance in mind to eliminate a lot of the bad practices or the idiosyncrasies with HTTP 1.1. And we ran a test on the new ft.com where we A/B tested it with HTTP2 enabled versus the same devices with it disabled, and you can see that we had 1,000 milliseconds shaved off just by using that new protocol. I'd love to be able to come back and do a whole talk on this. It's truly going to change the way that we think about and build our applications. It's a myth that we can't use it. We can use it today. This is the browser landscape for HTTP2 at the moment. Please go out there and start investigating whether or not you can use it. Now, I'm sure you've all seen a screen like this before. This is literally the story of my life. It's been cut off there, but it says waitingforfonts.googleapis.com. Every day I see a blank screen and it tells me it's waiting. Why do we have this reliance on custom fonts? I hate it. And the reason why we have that is, like all good things in life, browsers all chose differently of how they implemented the way that we load fonts. For once, I, Chris, have done the good thing here, I think, anyway, that they just show the fallback font first whilst the font's downloading, then they swap it. All Blink and Chrome-based browsers, they wait for 3 seconds, like, yeah, actually, I don't want to cause this yucky flash of uninstalled content. Someone at Apple decided you really like custom fonts, and if they don't download, you're not getting anything. Right? I don't know what happened there, but that is the worst decision ever. And that's so if that request failed, you're not going to be able to read that article of content that you came for, ever. The good news is the CSS font rendering specification is going to change this. It's giving the control back to us as designers and developers now. And so we're going to, a new property at FontFace, we're going to be able to declare the behavior. Say, for this font, I want you to swap. I want you to show the fallback. Once it's eventually downloaded, then you want to swap out. For this one, I really care about it. I want you to block. Unfortunately, this isn't in browsers yet, but at the end of this year, it should be in most of them. But this talk is about modern techniques for building resilience. So enter the service worker. The service worker is a new JavaScript API that allows us to create it allows us to create a proxy in between our applications. For anything going out of the web page, we can intercept those requests and choose to send them back to the network or respond to them. We now have a programmable cache API that we can store resources. The first time we've actually been able to program the cache of our browser and respond to them. But amazingly, for offline, if there is no network, I can synthetically create a response. If there is no network, I can still respond to the user with something. This, for the first time, gives us the ability to create truly offline experiences on the web that our native counterparts have had for years. We can, on the install event that expose, go and cache fonts for later. So once we've cached them, the next fetch request round, we can check to see if that request was for something like a font. I can then respond to them out of my cache, having instant rendering fonts and pages. So that's what that looks like. The first time round, is it in the cache? No. OK. The next time round, go and asynchronously load them, put them in the cache. So then, next time that I ask for fonts, I can have them instantly rendering and not even worry about failure over the network. This pattern and a lot more can be found at Jake Archibald's seminal resource, the Offline Cookbook, and it goes into much more elaboration about the power that service work is going to give us and these patterns. I spoke to a colleague in China recently, and he told us that the Chinese firewall even sometimes blocks their CSS on their own CDN. Therefore, they wouldn't even be able to render ft.com China. And so I started thinking, how could we use patterns like this with the service worker to solve this? What if we tried to always fetch the asset from the network and then fall back to a cache version if it fails, acknowledging that failure? So we, with the fetch event, we try and go and get it. If the response wasn't OK, then go and get it from our cache instead. And if it was, revalidate our cache for the next time the user comes around. Earlier, I discussed about how adverts can cause blocking single points of failures for us. What if we could imply a service-level agreement and say, OK, every request on our page must respond within 3 seconds. If it doesn't, then I can just return a timeout and at least unblock the UI and let the user carry on with what they're doing. So here, the service worker, when the request is made, I also start a timer. If the timer returns before that does, then we can fall back and fail. That's what that looks like. I'm just using promises.race. Apologies for having to race through this. I'm running out of time. The last pattern I wanted to show you is what we call the dead letter queue. So sometimes we do want requests to go out. Maybe a bit of user data has changed, and you need it to make to the database, but you don't actually care if it didn't happen this time, or an analytics request. So we make the request, the network's offline, but we store it for later. And the next time the device comes online, then we can queue up all of those things in our dead letter queue and send them. And the reason why we can do this is service worker exposes a sync event. So we're creating the queue. If the request fails, we're putting in it. But the sync event is going to be fired whenever our device comes back online. And think about the possibilities of this. You know when the network state has changed. So again, when I was talking about conveying the state of messaging to a user, we can use the sync event to do this. And then we can replay the requests afterwards. So we've learned that we need to pre-connect our sockets, try and pre-fetch and cache critical resources, serve stale and revalidate where possible. If you don't even have a network, just serve stale if there's an error. Always set timeouts on all of your requests. But most importantly, start thinking about how you can treat the network and as an enhancement layer, not always rely on it. So I just want to leave you with a few thoughts on the future. Now that we understand what this power, that the technology such as service workers give us, and we know that failure is going to happen, what are the future giving for us to be able to overcome these problems? And this is what people like Alice Russell are coining progressive applications. We need to be striving to create offline experiences that are truly agnostic of the network. So what we're doing and we're building the new ft.com is we're always going to show the user something, even if the network is offline. So instead of loading all of the articles, we can't do that, but we can show them the saved articles because we've used Service Worker to cache them for later. And we're telling them they're offline, but here are some of your articles that you can read on the tube. Service Worker are now exposing a push event that enable us to display OS-level notifications now. For the first time, websites can actually show you a notification, not just native applications. We have this running in production already at the FT. And the most powerful one for me is the background synchronization. Imagine a news website that before you've even woken up in the morning can synchronize all of its data in the background for the whole, all of the news for that day, so that when you don't go on the commute and you don't have a network, you've already got all of that synchronized in the background. Finally, we have the lower level primitives that the web application stack has always needed, and that's where our native counterparts have been beating us. But most importantly, we can be building resilient applications. So if you're going to take away one thought from this talk, please just let it be this, that by baking in the assumption that everything can and will fail, and use this knowledge to design and build resilient applications that truly embrace the unpredictability of the network. Thank you very much.